Hey everyone, Mrs. Spatola here. These are the answers from the challenge page that we had in class yesterday. Number 5 and number 6, as you can see. Then we had 4 practice problems. If you didn't get to finish them, that's okay. It's always a good thing to challenge yourself. So if you did them, hopefully you did a really good job. And that's what we have for that page. Now to our original homework page. This was the workbook page that was assigned for homework. There are many questions on here that you could easily see on an upcoming quiz that we have next week. Remember, the vocabulary terms are going to be very, very important. Terms such as coefficient and exponent and constant are all things that you should be very, very familiar with. A suggestion is to make index cards. I believe I have a Quizlet, so I'm going to see if I can link it up to one of your Google Classroom lessons. This way you don't have to make one. It's already made for you. But index cards, making index cards are always a great, great tool and strategy to help you with your vocabulary. So here are the answers for 1 to 5. I'm just going to slide it down. There's 6 and 7. And then we have number 8 are the pairs of expressions equivalent. Remember, when we come around in the classroom, we should always see solve, show the work. So for the first one here, you can see that it's 24x minus 12. Is that the same as what's here? Yes, it is. Again, for the next one, 12y plus 6x. Is that the same as 18x? And the answer is no. You cannot combine like terms with adding. You can multiply, but you cannot add. And then lastly, here's a blast from the past. We have some kids or people running a race, and there are 4 people. You have to put them in order from fastest to, well, from first to 4th place. Remember, the fastest time is going to be your smallest time. You will be seeing this again before the end of the unit. Hint, hint. Okay, let's take a look at today's lesson, which is going to be factoring expressions, also known as the reverse distributive property. Here we go. Unit 6, Lesson 5, Factoring Numerical Expressions. How can you factor numerical expressions? Let's start with the do now. What is a numerical expression? Well, let's think back. This is something that we've covered in the past. Numerical, when we think of the word numerical, what do we think of? Good. We think of numerical, we think of number. So a numerical expression is an expression with numbers, and what else does it have? With numbers only, and operation signs. Good, and operation signs. So let's get that down. Okay, the opposite of that would be algebraic, and we'll be looking at that soon. Okay, algebra, right? So numerical expression is an expression with numbers only and operation signs. We use the greatest common factor, or the GCF, and the distributive property to factor numerical expressions. This is what we call the reverse distributive. So when we start out with this, it's going to seem a little unusual, but then you'll start to catch on and you'll start to see it. Just like with anything else, it's going to take a little bit of practice. So let's look at our very first example. And the example is as follows. Factor the sum of the terms as a product of the GCF and a sum. Well, what does that mean? It says factor the sum. So when we factor, that means that we have to figure out what are the numbers that multiply out to that particular number as a product of the GCF, the greatest common factor, and a sum. So the first thing you're going to do is you're going to find the GCF. Okay, so you're going to find the GCF. So when I look at the GCF, I look at 27 and I look at 39, The GCF is what? Well, if I have to, over here, here's 27 and here's 39. I want to find the GCF of 27 and 39. Well, if I go ahead and I do that, I find that the GCF is 3. So basically, what is the largest number that goes into both of the terms? Each of those are called a term. So once I find the GCF, what happens is I say to myself, okay, the GCF is 3. I'm going to follow here. The terms are 27 and 39. Find the GCF. The GCF is 3. Then we're going to rewrite each term as a product with the GCF. So in other words, we're going to look at this, divide each term by the GCF. You're going to divide. So 3 times 9 equals 27. 3 times 13 equals 39. And your final answer. Now look, that's the distributive property, and you're applying the distributive property. So you're going to have the 3 here, the 3 here. So the 3 goes on the outside, and then your 2 terms go on the inside. And there you have it. Let's take a look at some more examples. Please rewrite the steps. It should say steps. This should be 1, 2, and 3. I'm not sure why that settled up like that. Okay, so step 1, steps to factor numerical expressions. Step 1, find the GCF of both numbers. You can use the T-chart or factor tree if you want. If you're good with your facts, you can probably figure out what the GCF is. Please make sure it's the greatest common factor, not just a common factor. Step 2 is going to be to rewrite each term as a product using the GCF, and I'll explain how that works as I go along. And then number 3, rewrite it using the distributive property. Okay, ready? Here we go. Number 1, here's some practice. 24 plus 40. What is the GCF of 24 and 40? And if I look at both of them, I can make a T-chart. I can do 24. I can do 40. But I know my facts, and I know that the GCF of 24 and 40 is what? It's 8. Now, I take that 8, and I am going to multiply each term. 8 times what is 24? 8 times 3 is 24. Plus 8 times what is 40? 8 times 5 is 40. So what do I wind up with at the very end? 8 times 3 plus 5. There are a number of different ways that I could check that to see if that was true. One way would be to add 24 plus 40. I see that that is equal to 64. If I wanted to check it and I wanted to apply the distributive property, I can continue and say 8 times 3, which is the 8 times 3 above it here. 8 times 3 is 24, and then 8 times 5 is 40, and that brings me right back to where I started. So I know that 8 times 3 plus 5 is going to be 64. Okay, let's take a look at number 2. We'll start to get in a groove, and then it'll start to flow a little bit easier. The more practice we do, the easier it gets. All right, number 2, 30 minus 18. We're going to factor the numerical expressions. It is a numerical expression because it only has numbers. So the first thing we're going to do is we're going to find the GCF. So I'll do this right next to it, GCF. So what is the GCF of 30 and 18? I look at it, and the GCF is 6. Good. Next, I'm going to break down the 30. Ready? 6 times, what is 30? 6 times 5 is 30. Minus 6 times, what is 18? 6 times 3. And then my final answer becomes 6 on the outside Now this is a minus subtraction problem, times 5 minus 3. And I'm done. And there you have it. Let's go on. Number 3, GCF. And I'm following my math recipe. Number 1, find the GCF of both numbers. Number 2, rewrite each term as a product using the GCF. And step 3, rewrite it using the distributive property. So my final answers are with the distributive property. Number 3, GCF is of 21 and 42. Be careful on this. Be careful. How many of you thought in your head it would be, oh, it's 7? It's not 7. Watch. If I have 21 and I have 42, the GCF is going to be 21. So be careful. My GCF is 21. So 21 times 1 plus 21 times 2. That was mean. That was tricky, Mrs. Spatola. And then finally we have 21 on the outside, and then 1 plus 2 goes on the inside. So hopefully you're starting to see a pattern. Using number 3, let's see if we can find it. So when I find the GCF goes 3 places when I'm factoring. I factor each number. The first one was 21 times 1. Then the next number was 42. That was 21 times 2. And then finally, when I rewrite it using the distributive property, the 21 goes on the outside, and then the 2 numbers on the inside go inside the parentheses here. So that is called the reverse distributive property. Let's go down and look at number 4. Number 4, the first thing we're going to do is we're going to find the GCF. So the GCF of 27 and 54, be careful. Again, it happens. Oh my goodness. The GCF of 27 and 54 is 27. Pause the video, try it now, and see if you can finish this problem on your own. And the answer for number 4 was 27 times 1 plus 7. Let's go on to number 5. Number 5, what is the GCF of 60 and 12? The GCF of 60 and 12 is 12. Then I'm going to rewrite my problem with the GCF of 12. So 60 is 12 times 5 minus 12 times 1. So using the reverse distributive, what's going to happen? I know I'm going to have something here, and that's going to be subtraction. So what am I going to wind up with? 12 on the outside, 5 minus 1 on the inside, and we're done. Let's take a look at number 6. What is the GCF? The GCF of 36 and 54. The GCF of 36 and 54 is 9. Good. Pause the video, complete it, and see if you can do this one on your own. And there's your final answer for number 6, 9 times 4 plus 6. Again, just to bring it to your attention, with this, you find the GCF. That goes there. The GCF is then used to factor each term. 9 is the GCF. 9 times what number is 36? It's 4. And then 9 times what number is 54? It's 6. Lastly, the 9 goes on the outside. What goes on the inside? In the parentheses, the remaining 2 numbers. Let's take a look and try 7 and 8 on your own. Pause the video. And there are your final answers for number 7. The GCF was 5. And for number 8, the GCF was 4. And there are your final answers. Please make sure you're asking questions, and also please make sure if you have any questions, you can always reach out in the Google Classroom. Let's take a look and see what's on the next page. So this is going to be your homework page. You're going to complete each one. You're going to find the GCF for each one. So even right away next to each problem, you can go ahead and write GCF for each one. And then you're going to do the same thing we just did on the previous page. Once you find the GCF, you're going to set it up. And your final answer is going to be for each one a reverse distributive property. So at the end of each problem, you should wind up with numbers that fill in these spaces. So numbers 1 through 9 are going to be very similar. Now be careful, numbers 8 and 9 have 3 numbers. So you have to find the GCF of all 3 numbers for number 8 and number 9. Now look what happens. Number 10 becomes a little bit more challenging. 10, 11, and 12, I do expect you to try. You're looking for the GCF now of 4 numbers. The challenge problem is the very last one. Remember, it's always a good idea to try to challenge yourself, and you can definitely do it. Okay, this is definitely the challenge problem. Take a guess, try it. You're going to find the GCF. Yes, there is a decimal. I can actually see it in the challenge problem. Alrighty, and that's all we have for today. The rest of this you're going to complete on your own and try your best. For now, this is Mrs. Spatola wishing you a great day, and remember, always be kind.